In the tense early years of the Cold War, the Soviet Union remained largely a mystery to American intelligence agencies. The Iron Curtain descended across Eastern Europe, concealing military installations, industrial capabilities, and the true extent of the communist threat. Daring U-2 spy plane overflights provided some insight, but an urgent need remained for a more comprehensive view behind the Iron Curtain. The solution emerged in the form of America's first imaging reconnaissance satellite program, Corona. This ambitious technological endeavor, pursued jointly by the CIA and U.S. Air Force, would revolutionize intelligence gathering and play a pivotal role in the Cold War's strategic cat-and-mouse game between the superpowers. In the wake of Sputnik's launch in 1957, the drive to develop advanced reconnaissance satellites took on new urgency. President Eisenhower established the top-secret Corona program in 1958, placing it under the leadership of CIA physicist Dr. Albert "Bud" Wheelon and the renowned scientist Dr. Edwin Land, the inventor of the Polaroid camera. Wheelon and Land assembled an elite team of engineers, scientists, and intelligence officers to tackle the immense technological challenges. They envisioned a satellite equipped with a camera that could photograph broad swaths of the Soviet Union and other denied territories. The exposed film would then be secured in a re-entry capsule and parachuted back to Earth, where it could be retrieved mid-air by an aircraft on the correct trajectory. Developing Corona was an immense undertaking that pushed the boundaries of aerospace engineering. The satellite had to be compact, yet capable of housing a high-resolution camera, a complex film processing system, in the re-entry capsule. Precise attitude control was essential to keep the camera steady and aimed at its targets. Lockheed was contracted to build a satellite bus, integrating the camera system developed by iTech Corporation and the film recovery capsules from General Electric. Immense secrecy shrouded the program, with components being manufactured in specialized black factories to maintain operational security. After years of intensive development, Corona finally reached the launch pad in 1959. However, the first 12 missions ended in failure due to a multitude of technical issues: faulty electronics, camera malfunctions, and capsule recovery problems. The program burned through its budget as skeptics in Washington questioned its feasibility. But the CIA and Air Force persisted, driven by the tantalizing prospect of penetrating the Soviet veil of secrecy. On August 18, 1960, Discoverer 14, the first successful Corona mission, achieved a breakthrough. Its camera operated flawlessly, capturing over 1 million square miles of the Soviet Union, and the capsule was successfully recovered after re-entry. With Corona's triumph, a steady stream of high-resolution imagery began flowing to intelligence analysts, offering an unprecedented look into the Soviet military-industrial complex. For the first time, the U.S. could accurately assess the extent of the perceived missile gap with the USSR. Corona's cameras mapped Soviet nuclear facilities, tracked the construction of missile silos, and monitored the Kremlin's production of strategic bombers and submarines. This insight was invaluable during the Cuban Missile Crisis, confirming the presence of Soviet nuclear-tipped missiles on the island and allowing President Kennedy to respond with a naval quarantine. In the years that followed, Corona's technological capabilities continually advanced. Improved cameras boosted resolution from 40 feet to an astonishing 6 feet by the program's conclusion in 1972. Over 800,000 images were collected, forever altering the strategic balance and ushering in a new era of overhead reconnaissance. Though shrouded in secrecy for decades, the Corona program's pioneering role was finally acknowledged in 1995 when its existence was declassified. It stood as a testament to American ingenuity, perseverance, and the relentless pursuit of intelligence to safeguard national security during the Cold War's darkest days. More importantly, Corona paved the way for subsequent generations of spy satellites that monitor potential threats, verify arms treaties, and provide critical strategic intelligence to policymakers and military planners. The legacy of this ambitious endeavor endures in the modern reconnaissance capabilities that preserve America's strategic advantage in the 21st century.